Please welcome to the stage Dana Weigel.
Thank you all for being here this afternoon. Our success in low Earth orbit over the last 25 plus years of crewed operations is because of you. Our congressional support, industry's dedication, and our strong international partnerships. Today, I'm going to talk a little bit about low Earth orbit and future plans. It's critical that we maintain a presence in LEO, transition to commercial stations, and the challenges that we face. As Jared mentioned, the options going forward. Apologies for that. We spent an hour before this fixing the teleprompter, so I have a handy backup here if we need it. All right, let's get started. Let's go ahead and go to the first slide. The next first slide. All right, I'll talk as we're figuring out the slides. Our objectives in low Earth orbit have not changed. NASA's core objectives are to maintain America's superiority in space with continuous crew presence, to continue conducting groundbreaking research, technology development, human research, and using LEO as a proving ground for exploration. We want to expand commercial access to space, stimulate commercial demand, and foster economic growth. Of course, space station will end, and we also need to plan for the responsible retirement of the space station and transition to future commercial stations. Building a replacement for ISS is a national imperative to maintain an orbital laboratory and a proving ground in LEO. Developing the station took worldwide and industry commitment. We had a massive team of major aerospace firms with 4 prime contractors and over 500 subcontractors and suppliers. We also had major contributions from our international partners, and of course they had hundreds of suppliers as well. It took 37 shuttle launches and over 160 spacewalks just to assemble the space station. And of course the Russians, who provide all the propulsion for station, also had a large number of launches. We spent over $50 billion across shuttle and station assembling station, and to date have spent $100 billion. It took us about 10 years to get to the point where we could really do research on board space station. And of course today, station is a world-class laboratory with capabilities that have enabled over 4,000 research experiments from 5,000 different researchers across 110 different countries. Over 290 people have flown to the space station from 26 different countries. Today, ISS is serviced by multiple crew and cargo missions to maintain our crew of 4 and the amazing research that we do. The operational tempo is high, with a dynamic activity about every week and a half. Our success over these 25 years of crewed operations was forged through significant failures and anomalies. We have overcome them through relentless, high-stakes human intervention. I want to talk a little bit about some of the challenges we've faced because we are operating in an unforgiving environment, and any future station will encounter similar challenges. We lost Columbia. That grounded the shuttle fleet for 2 years. We relied on our Russian partners to bring our crew home and to subsequently launch our crews and resupply for 2 years. We lost transportation vehicles like SpaceX CRS-7, Orbital CRS-3. We lost the cargo on those missions, but those fleets were also grounded for a period of time as a result of that. That really highlighted the importance of redundancy and resiliency in transportation and the criticality of having a robust resupply strategy. Since assembly complete, we've conducted over 110 spacewalks to either repair, replace, or upgrade space station systems. The picture here that you see on the screen, that second picture, is an image of a torn solar array that was damaged from micrometeoroid debris. Of course, that risk of micrometeoroid is inevitable for any spacecraft operating in low Earth orbit. In fact, we've done 41 debris avoidance maneuvers over the life of the space station. This particular repair was time critical. It happened during a shuttle mission. We were able to get a crew out there on the end of the robotic arm and kind of tie it up and repair the array. We've also had to overcome numerous major vehicle and spacesuit anomalies and medical incidents like the recent medical evacuation that we had from station. Some of these anomalies have been significant, like the image there shows water that flooded a crew member's helmet during a spacewalk. We came close to losing a crew member, and it grounded our EVA spacesuit fleet for a year. Many people have asked me if the vehicle failures we see on space station are related to the age of the station. They are not. We had higher failure rates earlier in station, and we invested in hardware changes and redesign. And so today we actually have improved reliability, so our failure rates have decreased. It took 30 years and significant investment to get space station's state-of-the-art life support systems to the performance targets that we have today. We have now reached 98% water recovery, which is pretty close to our Mars target. Not quite there, but pretty close. These are some of the most complex and unique space systems that exist, and they're also where we carry some of our highest time-critical risks. Any future station will encounter similar failures and challenges. Overcoming them will require expertise, robust capabilities, and strategic planning. Building and managing a station is not easy, and it is not inexpensive. Next slide. Speaking of the space station, next up we have for you a very special message from the onboard Expedition 74 crew. If we can please play that video.
Hello from the International Space Station Expedition 74 crew. It's an honor to join you today for Ignition. As I look out the cupola window at the thin blue line of our atmosphere, we're reminded every day why your discussions are so critical. For over 25 years, the ISS has been a masterclass in what humanity can achieve when we work together as a team. Its construction was an effort that required 37 launches, over 160 spacewalks, and the unwavering commitment from both industry and international partners.
Together, we've used this orbital laboratory to search for cures to the most challenging diseases, advance life-saving technologies, and prove that humans can live and work continuously off-planet. As we look forward, we need to ensure that the next low Earth orbit space station can build upon these amazing discoveries.
Our mission now is to ensure there is no gap in our presence. Replacing the ISS is a national imperative. We are eager to pass on the torch to a new generation of resilient commercial LEO platforms that will continue this critical research and propel us further into deep space. The challenge ahead is significant, and the tenacity and partnership that enabled us to succeed on ISS today are needed to realize the space stations of tomorrow.
The ideas you are discussing today are the blueprints for that future. It will take the same level of worldwide and industry dedication, along with sustained funding, to make this transition a success. We are excited to see the innovation and ideas coming out of Ignition. We look forward to the day we can hand over the keys to the next great outpost in the stars. Thank you for your commitment to keeping low Earth orbit open for discovery into the future. Thank you, and goodbye for now.
All right, it's always great to hear from the onboard crew. They've been pretty busy up there. They had a spacewalk last week. We've got another one next week. And even more fun to watch them having fun flipping around in microgravity. All right, I want to switch gears a bit, and I want to talk to you about what we have seen with the commercial market over time. I think most of you know it has been a priority for us to use the International Space Station as a platform for commercial access and also to stimulate commercial demand through a number of different avenues. We have had 4 fully commercial private astronaut missions. We have 2 more that have been awarded and that we're working towards. The Russians have also flown 8 spaceflight participant missions. We have offered the use of ISS ports for commercial modules and a commercial airlock. In fact, the airlock is on board today and operational. We share facilities across NASA and the commercial community, both NASA facilities used by commercial and the other way around. Some of those are inside the vehicle, and there are a number that are on external platforms. We also support commercial R&D through our ISS National Lab, managed by CASIS, and also through a number of unique and standing ISS calls for commercial opportunities. After more than 25 years of crewed operations, we have seen some amazing discoveries on station. But we haven't yet seen breakthrough products, capabilities, or services that generate significant demand. NASA's still subsidizing the infrastructure costs, like cargo upmass, which is really one of the largest costs you have in getting to orbit. We haven't seen evidence of scaled space-derived product that's manufactured on Earth or in space, although that is certainly the hope for the future. We have had a lot of technologies that have been adapted for ground-based purposes. You see those stories all the time, but they haven't driven continued demand for access to space. Tourism hasn't really materialized as a market. We certainly have had a number of tourist-sponsored missions, but those have been limited, and we haven't seen recurring demand for them. Sovereign governments do have interest in flying. We've seen purchase of tickets for short-duration flights, for example, on private astronaut missions, but no sovereign governments have been willing to purchase the long-duration opportunities, even though those have been available. When it comes to developing or maintaining the cost of a station or long-duration flight opportunities, our partners and other sovereign governments want to do in-kind barters or exchanges and keep the money flowing into their own industries. Suborbital flights, which are substantially lower cost, have suspended operations for either investment reasons or to prioritize other higher potential opportunities. Though we have seen investor interest, there's no independently verifiable market research indicating the economic viability of a commercial station that is only partially funded by NASA. We welcome industry input and thoughts on the market, but it is paramount that we have independent data. Station will end. The replacement path has to be economically viable and technically capable, or America gives up its leadership in LEO.
And this is a big takeaway for all of us here that, you know, we have over the last several months been very transparent with the world about where we see issues and where we see challenges in the development activity, everything we're doing. And this is a big area, and we want to be very clear about this before we maybe be a bit more optimistic about ways we can go forward. But this is a real challenge. It's a real problem. We know our presence in LEO is an imperative nationally. It's directed not only that, but also it's for every possible reason we can imagine. Having our presence in LEO is absolutely a national imperative. We cannot get that wrong. As Dana said, there is physics votes last. The current vehicle we have, which is an amazing machine, will eventually not be usable. By the mid-2030s, we will have structural and other issues that will preclude it from being useful. And we have to get the replacement approach right. We can't entertain fiction on what that approach might be. It has to be grounded in reality. As Dana mentioned, as the crew mentioned, as we all know, everyone in the room I'm sitting at helped us do this. Building space station was incredibly complicated. It took a long time. Maintaining it is just as complicated. The number of times we've had issues where we, had to take major action is uncountable in my mind. We've development, assembly, sparing, logistics, resupply, all the things that go wrong with these complicated systems will go wrong. It's not a question of modern technology. It's a question of the environment that we're putting them through. And right now, the current industry that we have that's proposing to build destinations does not have the direct experience with that or the resources to go do it. That's just true. We want that to be the case, but an operational campaign of this complexity that took the allied governments of the world, 30 years to maintain, is not something that exists native in industry. There's no self-sustaining market to finance that as well, and so, as Dana mentioned, we have not seen independent data. This is the estimation of NASA. We would love to hear independent analysis on this subject. that nations, companies, or individuals beyond NASA will create enough demand to cover the real gaps that it's going to take to build a replacement. And separately, as we also mentioned, that transportation costs have not decreased in a fashion that allow us to really achieve those savings. And so, in the absence of a mature market and the current budget that we've been allocated, we cannot fund a path of 2 stations. It's a challenge to even fund one. We have multi-billion-dollar shortfall just to fund 1 station as a replacement. And the environment we're in right now sets us up for a winner-take-all with an uncertain outcome. You guys know that even in non-space commercial markets, there's a higher than 50% failure rate. When you add the complexity of maintaining humans living in space and the environment that they have to deal with, that makes it even more challenging. And so this is all to say that we recognize this challenge. We really want to partner with all of industry and with everyone that's in the room to go fix this, but we cannot continue to maintain the illusion that the path that we're on is going to close. Dana, back to you.
All right, thank you, Ahmed. All right, let's talk about the path forward. Let's go to the next slide. Doing nothing is not an option. We need to take proactive steps to achieve our goals. The government can't force a commercial economy, as you heard Jared mention earlier, but we will try to do everything we can to ignite one. We'll increase commercial access to ISS. We'll increase the number of private astronaut missions, allowing the sale of the commander's seat, the potential for doing joint crew missions between NASA and industry, consideration for NASA purchasing a PAM seat, and prioritizing research with high commercial potential. We also welcome ideas and input from industry for addressing any of these challenges and risks that we're talking about here today. We are open to continuing with the current commercial path that we have been on, or to pivoting to a new preferred option that I will share with you today. Let me talk a little bit about the original path that we were on, where we've been headed, and what that original path is looking like today. Our original goal was to transition directly from station to commercial stations. As everyone knows, we had planned to have 2 commercial destinations to maintain redundancy and competition, and to be one of many customers. NASA anticipated significant demand from tourism and other markets. We assumed that this increased market would also drive large transportation bulk buys, which would in turn create and result in a discount for all of us. As a result of the strong market, NASA assumed we were no more than 50% of the overall demand for a commercial station, and that the market would be self-sustaining. With today's market and budget reality, we don't have that. So the plan for today's approach would have to be adjusted. Transportation costs are increasing, not decreasing. With NASA positioned to be the majority customer, we cannot afford 2 space stations. This means NASA would have to down select to a single provider, which carries higher cost growth risk and a higher overall risk for success of the campaign. It puts us in a sole source services environment, which doesn't allow the continued competition to help control pricing or to continue to grow the market in a diversified manner. So I want to talk about an alternate approach. So we'll spend a little bit of time on this since this is new to everyone. We are looking for feedback on both options. In this alternate approach, we're using an incremental or phased approach to reach commercial destinations. Recognize the challenges that we've highlighted. This approach uses multiple providers, continues to allow for participation of multiple providers, and drives continued market growth and commercial expansion. We'll use ISS as a platform for the initial assembly and to expand commercial opportunities. A NASA-procured core would serve as a hub for commercial module expansion, allowing for maturation of industry and continued demand growth. After the station detaches from ISS, there are flexible avenues that lead to commercial destination transitions. This approach also provides continuity in transportation, research, crew presence, commercial opportunities, and overall access to low Earth orbit. I just want to touch on some of the benefits to leveraging ISS before detaching a new station. Obviously, Space Station is fully operational, fully capable. We're supporting commercial opportunities on board today. We want to expand those, and we really want to see continued access to space for commercial companies and commercial access. ISS also has very mature capabilities and resources, and that's critical when you look at the types of challenges and anomalies that we may face. Having ISS mature systems is basically like having failure tolerance. It also provides a safe haven for the crew in the event that anything happens during the initial assembly. Any external needs can obviously be met with robotic and EVA capability. We continue the cadence with crew and cargo capability. And of course, any assets that we want to take from ISS can be transferred over to the new station and taken with us. This is a snapshot of the assembly or evolution of this concept. The first is a core module, which would be launched and attached to the forward of station. This core module brings with it additional docking ports. That would actually allow us to do more private astronaut missions. The big limiter today on board Space Station is the number of docking ports that we have available and the time available on those ports. Next in the sequence would be 2 commercial modules that would attach to the core. Obviously, I took Space Station out of this imagery just for clarity, but you can see the commercial modules radially attached to the core in the second image there. Before departure, we do outfitting of all the different modules and transferring of whatever assets we wanted to bring over from the space station. And then the new station would depart. Post-ISS, the expansion will be driven by the market and our continued objectives in LEO, with the next step being the addition of more capabilities such as power and cooling. That expansion would enable the addition of more commercial modules at that point, or if providers want to separate and operate independently and the market is mature, we will transition and shift to becoming one of many customers. Looking more closely at the core module, its purpose is to support basic capabilities for the station, including all the initial capabilities that the commercial modules would need. It would have systems like propulsion, power, cooling, basic life support, and compatibility with the existing crew and cargo transportation vehicles. 4 radial ports and a forward and an aft port allow both for the addition of commercial modules and for maintaining the same number of ports we have today for crew and cargo vehicle traffic. The core module would also have sufficient propulsion capability for the entire stack. Capabilities like attitude control, debris avoidance, which we talked about earlier, altitude maintenance, and refueling. It would also serve as a central command and control for the station, providing direct telemetry down to the ground, research data down to the ground, command and control. Next slide. The commercial modules themselves, they would be owned, developed, and operated by commercial providers. The commercial modules would have research and habitation capabilities that meet both NASA and industry needs. The modules would be attached to the core radial ports while at ISS. We'd like to see the development and operations set up through a partnering arrangement. That's one of the things that we'll be asking about with our RFI that will come out tomorrow, so we'd like input on that. When the market matures, we would transition from this partnered agreement to a services-based model. For future expansion, this architecture is really flexible, so there are a lot of options for future expansion. What we're really looking to do is use market indicators and industry needs to kind of drive and determine what this phase would look like. If commercial markets have matured, like I mentioned before, providers can separate, build up their own stations. We'll transition to being one of many customers, or we can add additional capabilities here. What you see in the vertical, in the image, the module in the vertical is the power and cooling module. That addition would allow us to add a number of additional commercial modules to the forward end of the station. There are a lot of new industry opportunities available here. With the expansion of what we want to do with Space Station. We are going to move from 1 private astronaut mission a year to 2. We're allowing for the sale of the PAM commander seat, which I know has been a challenge previously with the more stringent requirements we had with previous ISS experience. We will consider purchasing a private astronaut mission seat. We'll look for the potential for doing joint crew missions together. And as I mentioned before, prioritize research that has high commercial potential. And we're also open to other ideas that industry has for how to maximize the commercial use of the space station. Providers have opportunities to build 3 different modules. We have the core module and the 2 different commercial modules. And then there are many opportunities in the future for expansion as the market grows. This also continues our commitment to crew and cargo transportation demand through ISS and post-ISS. This is an overview of what the high-level procurement approach would be for this option. In the initial phase, the first phase, we have the 3 different modules. For the core module, we would select 2 providers and go through an early design phase point and then down select to 1 provider. And then 2 different awards for the commercial modules. Throughout this time period, we'll have multiple calls for expanded use of commercial access to ISS. The second phase will be informed by the market with the addition of a power and cooling module. We also envision 2 providers initially through initial design and then a down select. And of course, phase 3, either we're moving to independent free-flying destinations if the market's mature, or we can continue to add additional capabilities. Right now, the available budget is about $250 million a year, plus whatever else the agency can put together. That's true through the end of life of ISS. We will acknowledge that this is inadequate regardless of the option, regardless of the path that we take going forward. We are looking for industry inputs and partnering arrangements to help this challenge, but we're here to all acknowledge that we've had this shortfall for a while, and we realize this is a barrier. We're going to put out 2 RFIs tomorrow. One's for transportation feedback, the other's for destinations for both approaches. Then we'll have a final RFI. Expect to get a lot of comments from industry. We'll send out another one at the end of April, and then draft RFP in early June. So just to wrap up, you've heard us all say this, it is a national imperative to maintain U.S. leadership in LEO. Regardless of the path that we take moving forward, we have a real budget shortfall. So when you see those 2 RFIs tomorrow, please help us, give us feedback. We're looking for feedback both on the original plan and the original path we were on and this alternate approach and other ideas that you may have, including concepts for these partnership arrangements that I mentioned. We'd also like your feedback and your view on the market outlook and investments. Hard financial commitments to ensure stability from manufacturing through launch, long-term economic viability beyond NASA as a customer, and major technical hurdles that you see for a station development and your approach to managing them. We are committed to a rapid turnaround when we get your feedback to move towards procurement. Despite all the challenges I talked about today, and I know that's really hard for us to come forward and kind of transparently acknowledge that we need help. We're on a path that is not leading us where we thought it would. It's really important that we have this discussion. It's important that we hear your feedback. We're looking forward to creating commercial opportunities across industry, hearing your ideas, and establishing a trajectory that maintains U.S. leadership in LEO. Thank you very much for your time today.
And we will now head into a 10-minute break. Please welcome to the stage Associate Administrator of the Science Mission Directorate, Dr. Nikki Fox.
The universe is vast. Last year, the number of confirmed exoplanets passed 6,000. That means when we look at the night sky, more than half and likely most of the stars we see are accompanied by orbiting planets. And that means there is the possibility and indeed the probability of life beyond Earth. Science generates the big questions that we seek to answer, and as always, there is more work to do. The unasked questions will always outpace those we have already answered. With the administrator's full support, we are determined to do more science than ever. NASA routinely does what others think is impossible. Now, for each of you, this is your everyday, taking dreams and building them to reality. Our collective workforce is really, truly one of a kind. We are uniquely bound together by our mandate to explore the unknown in air and space, to innovate for the good and benefit of humanity, and to inspire the world through our discoveries. Science is the beating heart of this mission. Aeronautics, space technology, and human exploration are endeavors that we are proud to support and platforms that we use to expand the scope of our science. Every day, I wake up with the goal of getting more science into space at a lower cost for our taxpayers. Today, we will dazzle you with some space mission updates and debut a lot of new science ideas and new opportunities for us all to collaborate together. Much is still being developed, and there are definitely still some unknowns, but tomorrow and for the days and months to come, we will engage with our partners, current and future, to get your very critical feedback. Looking forward, we'll continue working together to mature those concepts. I think it's very clear to all of us that the science we can do together is exponentially more powerful than what any single organization could do alone. NASA is committed to continuing our legacy of leading the charge, but we need all of you behind us to meet our full potential. Next chart, please. When you look at an unbelievably beautiful image like this one, and I have to confess, they said, which image do you want? And I did choose my favorite one. But what you're looking when you look at this is not just a gorgeous image. You're actually seeing a visual representation of a tremendous amount of data. When you think that each pixel represents a new piece of information. In this case, it's light intensity at specific wavelengths, which we analyze to understand chemical composition, temperature, distance, the shape, the structure, and the age of the stars and galaxies that are too far away for us to physically reach, at least today. Why do we work so hard to understand these distant systems? Because when we solve complex technical challenges to answer big science questions, we push the cutting edge of technology forward. And science discoveries keep us at the front line of innovation and economic growth. This advancement always comes home to benefit us in the end, and it's critical, and actually it's often unseen. It's a critical way that the US maintains global leadership. NASA science is the tip of the arrow for the country's advanced technology strategy, piercing the furthest veils to shape our future. Technology invented for space often pushes whole industries forward. Measurement technology developed to support the polishing of the James Webb Space Telescope mirrors transformed optical fields ranging from laser eye surgery to the manufacturing of microprocessors. Now here you can see the very beautiful, incredible Roman Space Telescope, and you're actually looking at the clean room where the team continues to be super hard at work. Roman will have a deep panoramic view of the cosmos with a field of view at least 100 times greater than Hubble, and it will survey the sky 1,000 times faster while still maintaining similar sensitivity and resolution. Over the course of this mission, Roman will see hundreds of millions of galaxies. That is more than one for every person in the US. The sheer power of this data will rewrite our understanding of dark energy. As with past observatories, we're building first-of-a-kind systems for Roman, and we expect to see those spin-offs and industry applications for things like precision optics and powerful data processing techniques. Now, Roman is under budget and ahead of schedule, and you can believe I never get tired of saying that. I'm so proud of this team. We are learning from this mission and others, and we're actually ensuring that this isn't a rarity. I want to stand up here a year from now and tell you most of our missions are ahead of schedule and under budget. There's a challenge for you all. So we want that to be a baseline for our future. Successful demonstration of the Roman Coronagraph Imager, CGI, in early 2027 will represent the first successful milestone for the Habitable Worlds Observatory technology, and many of you are helping us to mature that technology today. Habitable Worlds is a concept for the first space telescope designed to directly image Earth analogs and study them for signs of life. For decades, NASA's space observatory like Hubble, Kepler, and TESS have led key insights into worlds outside our solar system. This time, NASA is taking a deliberate strategic approach to the future of this work while minimizing risks of cost and schedule increases. Now, as we peer deep into space, we're always looking for echoes of Earth. In our own solar system, we've identified high-priority destinations to search for conditions that may represent the potential for life. Our eyes are always on the horizon, and this is an incredible time for planetary science. Europa Clipper is off on its 1.8 billion-mile journey to seek out environments where life could exist below the icy shell of Jupiter's moon Europa. We have strong evidence that there is a saltwater ocean and beneath that sort of thick crust, and some very recent surface activity suggesting it could in fact be a habitable world. Now, the beautiful Dragonfly mission, which if you have not yet seen it, there is a 50% scale model. It's actually the integrated test model, and it has flown recently over the deserts in Utah. Please take a look at it, selfie with it, and then please tag us on when you post them. But the beautiful Dragonfly mission, which Forbes called the most exciting space mission of your lifetime, will launch a nuclear-powered octocopter in 2028. It will arrive at Saturn's moon Titan in 2034 to explore its complex, organic-rich environment. Now, it will be the first science vehicle to explore multiple locations on another world, performing vertical takeoffs and landings in search of evidence of prebiotic chemical processes and other signs of habitability. Now, because it can fly through Titan's dense atmosphere, Dragonfly will be able to travel much farther in a much shorter time than even our most capable vehicles on Mars. And talking of Mars, NASA Science has been flying missions there for more than 50 years, following the signs of water and chemical activity. Curiosity has spent a good portion of the last year exploring a region full of geological formations called boxwork that look kind of like giant spider webs when you view them from space. The proposed theory for this is that groundwater once flowed through these large fractures in the bedrock, sort of leaving behind minerals and making this a great location to do science. Last year, a new result from Perseverance brought us closest that we've come yet to discovering proof of ancient life on Mars. These rovers are our eyes on the ground, and they're so valuable as we plan for future human missions to Mars. The ever-flowing stream of new observations is a reminder that NASA Science leads the operational experience at Mars in orbit, on the ground, and thanks to my friend Ingenuity here, in the air. We have built the current understanding of the extreme environments with this evidence-based precision. And also, please take a selfie with Perseverance before you leave too. In 2028, NASA will launch and land ESA's Rosalind Franklin rover to Mars. Rosalind Rosalind Franklin will drill and acquire samples from a depth of about 2 meters, which is well below the radiation damaged surface, and then will determine subsurface structures in a previously unexplored region. The landing site is thought to contain extensive amounts of hydrated minerals that could be the source of extractable water. NASA is also very proud to be contributing the mass spectrometers for the Mars Organic Molecule Analyzer, or MOMA, instrument, which will result in the most advanced detection and analysis of organic matter ever conducted on Mars. The mission will add a new layer of insight into the planning for crewed missions and in situ resource utilization. Now, international partnerships have made many of NASA's most iconic achievements possible, and we are so grateful for the years of collaboration that has brought us so many amazing missions with these really, really incredible longtime partners. And we're equally as appreciative of our more recent partnerships, which are showing the world the value of being a spacefaring nation. When we work with international partners, we benefit from the unique knowledge, expertise, and national resources of our counterparts. But we get to also to share what we know, the NASA spirit that we always give to humanity. For humans and machines that are looking to survive and thrive in the extreme environments at the Moon and Mars, radiation, dust, surface dynamics, and physical hazards produce a lot of risk. Now, NASA has been studying these conditions and developing mitigations for decades. Radiation is an area where we've learned a lot, but we still have a lot of knowledge and capability gaps. NASA's heliophysics missions, both past and current, have helped us understand space weather here at Earth, but we're still far from the ability to forecast it like we do our own weather. To accurately model and eventually forecast solar activity and the resulting impacts on humans in space, we need to continue monitoring from various locations with a range of instruments. Now, to that end, in 2025, the Heliophysics Division launched actually their first dedicated mission to Mars, the ESCAPADE mission. It's made up of twin spacecraft that will provide simultaneous measurements of the Martian environment to study how it interacts with the solar wind and how, in turn, this drives atmospheric escape. ESCAPADE will definitely better help us understand the unique space weather at Mars as we prepare to send human explorers to the Red Planet for the first time. And this mission is demonstrating a new strategy that enables Mars-bound spacecraft to launch at nearly any time. Freedom from the restrictive traditional launch windows gives us the flexibility to increase the cadence of Mars exploration. I'll also note this is a great example of public-private partnership at its best, with the spacecraft coming from Rocket Lab and Blue Origin's New Glenn providing the launch. Now, for long-duration human missions, understanding how to grow food in space environment may prove to be critical. Pioneering research has been performed aboard the International Space Station for decades. You're probably familiar with the veggie experiment and the many types of plants successfully tended and now enjoyed by our astronauts in orbit. The ISS has been our destination for biological and physical sciences for over 20 years, but NASA Science is also very proud to use lower-cost platforms like commercial flight opportunities to complement this research. A core piece of NASA's mission to improve life for people here on Earth. NASA measurements and cutting-edge modeling underpin the infrastructure behind our highly accurate GPS system. NASA observations feed operational warnings that safeguard our internet connectivity and our power grids. Farmers use data on supply chains, and they can view the water levels down to the individual field level to allow them to really plan ahead and best make use of our precious water resources. NASA Earth science data is available and accessible to companies who use it to risk and optimize their operations. In fact, about 75% of Fortune 100 companies utilize NASA Earth data. When state and federal leaders need to respond to extreme weather, NASA data empowers operational partner agencies to take decisive action when literally every second counts. Next year, we will launch INCUS, which will for the first time measure the evolution of dynamics within a convective storm. Now, these dynamics determine severe wind, hail, lightning, and rainfall, and they'll improve the weather community's ability to forecast the evolution of a weather event up to 6 hours in advance of the event itself. This mission is a part of the Venture Class program, and it's another great example of public-private partnerships enabling NASA science. Earth science innovations also expand what is possible off our planet. The same tools, models, and insights we use to study Earth help NASA understand planetary environments as we prepare for future missions to the Moon and Mars. Right now, we're identifying more ways to apply our Earth research models to the Moon and later to Mars. With the Explorer for Artemis Geology, Lunar, and Earth missions, or EAGLE, there's a bad acronym for you, NASA will deploy breakthrough hyperspectral images across the Earth with later missions anticipated for the Moon and Mars in rapid succession. On Earth, they'll identify critical minerals for national security to enable precision agriculture and to support disaster response. On the Earth and at Mars, they will locate critical minerals and resources that enable water ice for propellants, for rare earth elements for technology, and construction materials for habitats. Now, I think it's extremely clear how very proud we are of the work that you all do. And we meet today at a critical moment that will shape humanity's future, and you all have a key part to play. The space industry is growing rapidly and is increasingly present in our daily lives. We are not the only ones interested in the Moon or Mars. Many of the technologies that have the most promise for health and safety of America can only be derived from work done in space, and we cannot afford to fall behind or cede leadership. We must evolve how we explore. We need to move faster, we must look further, and we must do it first. As the Administrator has very clearly established, achieving the agency's objectives is imperative for national security. When we stand by our commitments and investments and show the world what we can do, we secure the future of America. The administration's commitment to increasing launch cadence is broader than just Artemis. Not only will the increased tempo of missions provide more opportunities to do more science, but these kinds of bold decisions show us and show the world that we're ready to do what is necessary to execute the missions in the way that only NASA can. In the past year has brought a lot of change for many of us, both inside the agency and in our partner organizations, and of course in the science community. But we're now moving to a phase of clarity and action. We're being asked to examine what we do and how we do it. And this is how we grow together as an agency and as a community. And no matter what challenges we face, we continue to launch groundbreaking missions and conduct history-making science. The future of NASA science is bolder, faster, and more collaborative with commercial, academic, and private partners. Picture experiments done across a network of laboratories distributed throughout the entire solar system. Imagine a vital world of data that is alive, vivid, and easy to access. Our legacy, more than half a century of exploration, your passion, the late nights and the missed holidays, and this country's investment all brought to fruition. When farmers decide when and how to water their crops, the rainfall models and the real-time predictions will be there. When those of you on the Artemis mission planning teams reach for data on lunar topography, radiation, and temperature, it will be there. When a child asks, what would it look like to walk on Mars? Their imagination will come to life before their eyes. And this is extremely relevant now on the eve of Artemis II. Science is why we're going, and science is what we will do. The Moon is a scientific goldmine as we strive to understand planetary formation and the evolution of our solar system and deep space environments. It has the potential to address all of NASA's key science themes and major community science objectives across all disciplines. NASA science is leading the way in characterizing, mapping, and accessing the vital in situ resources required to build up a permanent presence on another planetary body. That wasn't me. From the early robotic lunar missions and through the Apollo era, We built the foundation for understanding the moon's origin, composition, and geologic history. The decades of robotic exploration since have advanced this knowledge with high-resolution mapping, multispectral imaging, and high-precision isotopic analysis, revealing an extreme environment shaped by complex processes. Today, missions like LRO continue to deliver an incredible amount of data, which NASA, industry, and academia use to feed, improve models, maps, and mission planning tools. Small and large landers, rovers, habitats and labs, access to power, and innovative systems like hoppers. This moon base is packed with science opportunities. We are so excited to partner with you to make this a reality. Now, you've heard today about the expansion of the CLIPS program to deliver more assets to the moon, and NASA science is ready to go. CLIPS has already been a great example of how the agency is acknowledging and evolving industry's role and putting a lot of trust in our partners to figure out these really complicated space and science challenges. These missions have already deployed valuable science and tech demos that are allowing us to plan safe and effective robotic and crewed operations on the lunar surface. The Firefly Blue Ghost mission successfully landed and operated 10 experiments for NASA, costing NASA less than a third of the inflation-adjusted cost of a single Surveyor robotic landing mission from the 1960s. And this is how we use our resources more strategically. The success for Firefly has resulted in a number of awards, including, and I just want to congratulate them on their most recent Robert J. Collier Trophy, the annual award for the greatest achievement in American aeronautics and astronautics. And I'm just going to brag, 5 in a row for NASA Science Collier Trophies. Yeah, I'm a bit proud. Utilizing the innovative power of the commercial sector to rapidly design, develop, and operate landers and orbiting assets while meeting the needs and requirements of hosted payloads in a perfect alignment with a future vision of how we do more science. So today, I'm really excited to announce that NASA has selected the next CLIPS lander. And so with that, congratulations to Intuitive Machines, who will deliver 7 NASA-sponsored payloads to the moon's south polar region. This is IM's 5th CLIPS contract, and the payloads are science instruments focused on volatiles and radiation, technology demonstrations for mobility, and they represent a multinational collaboration with several other payloads. So congratulations to Intuitive Machines. We're tracking up to 4 potential launches this year, and certainly Administrator Isaacman is accelerating the program, aiming for an aggressive target of 30 robotic lunar landings within 3 years, starting in 2027. We've seen the early success of this model, and we are so excited about continuing to ramp up lunar commercial services and assess how we may apply this to other things like Mars and maybe even other destinations. And to that end, we're planning to fly science payloads on the Mars telecommunications network and the nuclear tech demo mission, which you'll hear about up next. I mean, honestly, why waste a great opportunity to do groundbreaking science at Mars? The challenge from the administrator is a call to action to ensure there is science on everything launching to the moon and Mars. And that is where we need your help. NASA has previously obtained lunar payloads for delivery on CLIPS missions from a variety of solicitations, including LCIP and PRISM, including in-house builds, and including from our international partners. With the acceleration and increased number of CLIPS landings in 2027 and 2028, we need to identify flight payloads that support NASA's science and technology goals right now. So today, we're releasing a new request for information to help with this. I think it should have just gone live, and the RFI is open to all respondents. And we want to seek payloads that are ready in the near term and the medium term for delivery to the moon with this expanded monthly cadence of CLIPS lunar landings, or of course to Mars on any missions of opportunity I can tag along with. The proposed payloads will link, obviously, to NASA's Moon to Mars objectives and technology gaps. And I am really looking forward to see what you guys have on the shelf and ready to fly. In addition to the excitement of the expanded CLIPS program, NASA Science is thrilled to be part of Artemis. On Artemis 2, the Avatar experiment from our Biological and Physical Science Division will send cells derived from the Artemis 2 crew deployed on microchips to study the effects of increased radiation and microgravity on human health. We plan to use the data to work towards personalized medical kits for future long-duration missions. Additional science on Artemis 2 includes the Artemis Lunar Observation Campaign, or the ALOC, and they will be using photographs, videos, and crew observations to study the lunar geologic terrain and to look for impact flashes. An illuminated far side of the moon will allow for observations of the surfaces that have never been seen before by human eyes, even including during Apollo. It's going to be such an incredible moment. Hearing and seeing the crew put years of training into action, using lunar geology strategies to better understand a rarely seen part of the lunar surface, will inspire a whole new generation of scientists. You can see the team in the science evaluation room here. The SIR. They're running a simulation for the Artemis 2 lunar flyby here. And embedding science directly into the mission operations environment ensures we can maximize Artemis discoveries and sets us up for future success as we build up a strong community of scientists who will support our permanent presence on the lunar surface. Speaking of which, I am excited and pleased to share that NASA has selected 10 participating scientists to join the team developing the science plan for the first Artemis astronauts to set foot on the lunar surface. And this will include deploying scientific instruments, making critical observations of the landing site, and collecting those unbelievably precious moon rocks. So congratulations to this extremely qualified group, and please join me in yet another round of applause to celebrate them. So work is underway on the tools and the instruments for the lunar surface missions. We plan to grow the first plants on the lunar surface, use advanced rovers to assist the crew, and test technology that will close capability gaps for future Mars missions. Every component of surface science must seamlessly interface with the other hardware, things like the suits and the gloves. In addition to maximizing science across physical labs on the ground, also at the moon base and hopefully beyond, NASA Science is also developing a digital lab concept. Here we will incorporate and transform science data into a continuously updated central environment for all user groups. Through this, we will support the creation of new products for Earth, Moon, and Mars, where researchers, engineers, and other mission stakeholders will synthesize science data into products that are actionable for exploration, risk reduction, decision support, and discovery. And we're really looking forward to discussing the technological requirements with our industry and commercial partners in the coming months. Some areas we've identified as strong candidates for directorate efficiencies include integrated digital environments for real-time mission planning, for certification, for astronaut health analytics, for extreme environment computing capabilities, and advanced high-end computing for aerospace systems. So again, we're really looking forward to discussing the technological requirements with you and actually learning from the techniques that you have that we currently don't have. So really, really excited about doing that. Much of the value of the Science Mission Directorate is how we deliver to our end users, and that includes other NASA colleagues from other directorates, and it comes from our unique ability to integrate and layer results. We're already closing gaps between information and implementation, but we have to match the pace of exploration with the right science at the right time to answer those questions that have not yet been asked. We're already moving out on initiatives to support the administrator's vision for NASA and the executive order on ensuring American superiority in space. By finding efficiencies in our existing processes and tools, we plan to free up resources to do the next missions upon which the next generation of discoveries and science careers will be built. By expanding and evolving public-private partnerships, we'll be able to do more and bring more people along with us. By continuing to leverage the expertise and the hustle of our industry partner teams, we'll accelerate the pace at which data turns into decisions. We want to simplify the pipeline of information from doers to decision makers and to seek more agile and streamlined ways of working with our partners. We'll clarify decision authority, streamline reporting and briefing practices, and leverage the same advanced technology we use to do world-class science to support and empower our workforce. Moving faster means taking a hard look at every layer of our organization to target inefficiencies and red tape that are holding back our teams. Looking farther ahead means effectively integrating long-term science objectives with the known needs and priorities of the country, while building in the agility so we're ready to meet unknown unknowns as they arise. And being first will require not just NASA, but the entire space science community, including our partner agencies, industry, international partners, academia, and, my favorite, the rising STEM workforce. The many hurdles we must clear to move missions from concept to operations exist for a reason, but they often slow us down. Now, safety will always be NASA's top value, and we will always maintain the right to checks and balances. But to fully step into the new era of exploration, we need to take the same ingenuity and that we use to resolve engineering problems and apply it to how we do business. We must be willing to take on and manage risk when it's in balance with our groundbreaking science rewards. Now, rideshares are obviously one of the clearest examples of common sense efficiencies that provide massive savings. It is critical that we take advantage of every ounce of upmass. This is a strategy that's available to us on many levels. Now, we've recently launched multiple NASA missions on the same launch vehicle. Here you're looking at Spherix and Punch. We also launched IMAP with Carruthers and SWIFO for NOAA. We are looking at being able to do a sort of expanded CubeSat opportunities, and we fly small experiment payloads on human missions. So similar to Avatar that we have on Artemis 2, we'll seek every opportunity to do exploration enabling science on every subsequent human mission that we can. And we'll look for opportunities to fly those small but mighty technology experiments to multiple destinations to expand our data sets and to make the technology more resilient. Radiation monitors, for example, can be especially beneficial. Beyond rideshare, we're looking at every possible way to find cost savings in the way we do business. It is very clear that we cannot continue to spend hundreds of millions of dollars for legacy extended science missions particularly on their operations as their scientific value starts to diminish. Now, new approaches to science operations such as mission consolidation and AI-driven collaboration and scheduling must be applied to significantly reduce the costs of the operational portion of these missions in extended phase. The goal is to streamline the operational costs while maintaining the scientific value and support to the community. Getting processes, tools, and protocols consistent across missions is something that we have aspired to do for years, and we are really happy to have the administrator's full support in tackling this incredibly complex task. The agency's science portfolio is strategically designed to deliver the highest scientific impact with the available resources. The long-term trajectory is balanced with the extremely practical near-term priorities of the nation. We must maintain focus on addressing the needs that only NASA is equipped to meet. In addition to doing more science, we want to achieve it faster. And so SMD is investigating how to hone our acquisition approach while ensuring observation and preservation of NASA's core competencies. We will leverage NASA center expertise and streamline our procurement to facilitate broader commercial involvement. Tomorrow, we're going to host a discussion on how we hope to achieve this. We're investigating a new strategy for competitive PI-led missions that really do address our strategic science and exploration goals. The priority will always be given to the best science per dollar return. But we want the community to be thinking about how low-cost assets can enable science, how science-grade instruments can be flown on commercial platforms, and how, basically, we can get more shots on goal. This is an area where we're looking at extending the CLIPS-style approach in alignment with the administrator's priority to launch faster and in a more efficient way. We're also applying lessons learned from across our portfolio. For example, I mentioned already the Earth Science Ventures program. Now, they have an expedited one-step proposal process, and we're going to apply that model to this year's astrophysics solicitation for a small explorer, or a SMEX mission. Community announcement actually came out yesterday on this, and this will result in a much shorter time for missions to get to launch, and we hope also level the playing field for smaller institutions who may not have had the resources to compete in the more process-heavy mission solicitations. We're also going to discuss this tomorrow. We've got a lot to discuss tomorrow, and we're very excited to get your feedback on this streamlined approach. NASA Science is the vanguard for the country's advanced technology strategy. We are responsible for driving the most cutting-edge missions to answer the most ambitious questions so that human curiosity, technology, and industry can build on our achievements. NASA sets the standard. We go first. We confront the hardest risks, and we define the frontier that industry builds upon, scaling up what we've proven to be possible. Increasingly now, we're seeing industry pushing themselves farther and doing first of its kind work as well. As our partners expand what is possible commercially, NASA can turn its focus to what is possible for humanity. The audacious questions and challenges that no market alone would take on, but that NASA can unite a nation to pursue. Leveraging commercial capabilities helps NASA to increase speed, resilience, and national competitiveness. This interplay between public responsibility and private efficiency is one of the greatest strengths of the American model. As we look at our processes, we're working to bring industry in earlier. And so to that end, we are releasing another RFI for commercially owned and operated microwave radiometer capability to fly in formation with a NASA Earth observation fleet called Falcon. We believe there are commercial approaches to augment this fleet that increase efficiency and reduce time to science. And that is, including data buys, co-funded technology developments, many other ideas that you may have. And through this RFI, we hope to understand the interest from industry. Now, this is an Earth science mission, but this capability will also be applicable to exploration of other bodies. On Earth, the Falcon fleet will study the complex relationship between clouds and aerosols in orbit at Mars and at the Moon. This capability can support a wide variety of objectives, including site selection, operational risk and hazard assessment, and all-weather operational decision-making. Initiatives like this allow us to build the strategic infrastructure for America's space future. At NASA Science, we take very seriously our mandate to deliver space science for the nation. We are guided by community input and administration priorities. Available resources, of course, can limit what NASA can do as a single entity. But if we are able to share risks, costs, and expertise, we can achieve greater results and improve return on investment for our taxpayers. In this way, we are building a more robust and resilient commercial space economy. We're interested in expanding our reach into public-private partnerships to allow NASA to address more priority science objectives. We're really excited to see private entities taking an interest in this work as well, and we're happy to engage with philanthropic organizations to advance shared objectives in space science. One example that the administrator mentioned this morning is Schmidt Sciences, who will launch a private space telescope in 2028. We are also incredibly excited to hear that other private companies are undertaking missions to solar system destinations. If other private groups are planning to conduct science that is of interest to NASA, we really want to hear about it. We want to investigate if we can help enable your goals. And while we've not put out a formal call for these partnerships, we're looking forward to discussing some of these possibilities in the days and months ahead. Now, my most fun action I've had recently was when the administrator asked me to suggest some exciting mission concepts which are not possible within the scope of our current budget, but are of great interest to the nation, to the world, and would be right for such partnerships. One area that is of extreme interest to everyone is planetary defense. And this was exemplified recently by a visit from an interstellar comet. And here I am unashamedly also bragging about the power of the NASA fleet. Upon detection from the NASA-funded Atlas Survey Telescope in Chile in July of 2025, NASA quickly formed a multi-pronged plan to learn as much information as possible during the short window of the comet's visit, involving more than a dozen NASA missions across multiple scientific disciplines and with all of our international partners and ground-based observatories. Now, next year, we plan to launch the Near-Earth Object, or NEO Surveyor. It's an infrared space telescope specifically designed to detect and characterize large numbers of asteroids and comets that are potentially hazardous to Earth. But clearly, simply detecting these asteroids may not be enough. I'm sure you remember the brief period of excitement last year when 2024 YR4 was found to be on a path which could impact Earth or the Moon. Now, while our scientists have now confirmed that this is not going to happen, it certainly made us think about what would we do if there was such a real emergency. In 2022, we sent the DART mission to change the trajectory of an asteroid, and it was a huge success. But what is the next step towards developing and proving the technology and expertise needed for true preparedness? We're aware of privately funded concepts that intend to send missions to rendezvous with Apophis, and we're very interested in talking with these and other companies to investigate how we would quickly protect our planet from a potentially dangerous asteroid. We want to discuss how we could maybe form partnerships now that would allow us to take that quick action. How would we position ourselves for a rapid ramp up and launch in a matter of years? How would we use off-the-shelf commercial systems for rapid deployment? While not explicitly part of our current budget, we want to start thinking about how the next steps for our planetary defense program and lay the future groundwork. And now from new missions to the OG, everyone's favorite, Voyager. Of course, Voyager is famous for many, many discoveries, providing humanity the first encounter with the outer solar system planets. My favorite, the iconic pale blue dot image from a distance of 3.7 billion miles away, and now the first spacecraft to have left the protective bubble provided by our sun and traverse into interstellar space. This year, by the way, Voyager 1 will exceed a distance of 1 light day away from Earth, otherwise known as 16 billion miles, and yet still transmitting data back home. Voyager became a serendipitous interstellar traveler, but many community studies have looked at what it would take to move fast through the solar system and truly explore interstellar space. This would be a mission that would build on the legacy of Voyager to travel farther than any human-built object in history to explore our habitable astrosphere and uncover new worlds. This is another concept that would be ripe for innovative partnerships to create a mission that would bravely aim to rival the top speed of Parker Solar Probe. And you may be wondering what this image is. This is Da Vinci. Apart from being a very cool mission that is going to Venus, it will showcase technical and scientific innovation by returning to this deep, hostile atmosphere. Beyond that, this mission allows us to demonstrate probe technology, which is so relevant for other destinations like Titan, Europa, Saturn, Uranus, Neptune, and even the deep oceans here on Earth. You can think of it as a key milestone for a capability critical to the future of planetary science. The ice giant Uranus is arguably the closest analog we have to the most common exoplanets. Yet only one spacecraft has explored it. 35 years ago, yep, you guessed it, Voyager 2. The planetary science community has recognized this as the next destination on our path to understanding the origins of the solar system. The 60th anniversary of the Voyager 2 flyby could be celebrated by the arrival of the next visitor to Uranus. But we would need your help to make that happen. Building on the decadal mission concept and the technology from the Da Vinci probe, who wants to join us to enable a Uranus orbiter and probe? These are just a few examples of the big swings we could potentially take together in partnership with philanthropic organizations, private companies, and our international partners. We're extremely excited to hear from you tomorrow and in the conversations that follow. What are the concepts you're interested in bringing to life, and what other ideas at this scale do you have? There are many other science objectives that have been recommended as priorities by the community, and we would love to see them executed in the near term. These are the kinds of missions that move the cutting edge significantly, resulting in discoveries and tech developments that not only influence our science missions, but deliver value to the public. I certainly hope it is clear to you that we want to do more. And you guessed it, we're releasing another RFI. So the RFI for Science as a Service, which we're very proud of as it spans the Science Mission Directorate. We're seeking technologies needed to expand commercial business cases where NASA investments, think things like validation, flight access, integration support, etc., could reduce technical, schedule, or financial risk. The RFI will help identify NASA science mission concepts or technology demonstrations which could be attractive for commercial hosting, adoption, or downstream commercialization. Things like, instruments as product lines, data as a service, analytics, etc. And it will help inform NASA of operational and integrational needs that better align technology development with commercial development cycles, platform interfaces, and investment strategies. This and all the other RFIs we released today are just one way that we gather feedback and ideas and identify opportunities to collaborate. The science community tells NASA what its priorities are, and through a number of avenues, including the national academies, the decadals, conferences, and workshops. And when we go to those events, we aren't just presenting NASA's perspective, we are really eagerly listening to the questions that are asked and the themes that are top of mind. In fact, I've literally just come back from the National Academy Space Studies annual Space Science Week, where I had a chance to inspire that group with all of the great things at NASA Science. But before I close, I want to do one more big reveal. It is a brand new image from the James Webb Space Telescope. This is an infrared view of Saturn, and it's showing the icy, I said wow when I looked at it on Saturday afternoon. It's glowing icy rings, the layered atmosphere, and several moons, including Titan, which is the destination for our mighty Dragonfly mission. NASA represents the best of what makes us American. Grit coupled with creativity, strength merged with empathy. We must continue to lead. The world deserves to have curiosity, innovation, and peace to continue to reign in space. There is no doubt that the past months have tested us. We've gone through a lot of change, and much of it unexpected, but NASA has weathered periods of change in the past. This is our moment to be forged in fire and come out stronger with renewed commitment to our purpose. What I have laid out here today is a compass. It's a shared direction for how we think, how we operate, and how we lead the world in space. Over the coming months, we will redefine this vision together. We will integrate our teams more deeply around common challenges, continue to modernize our infrastructure and decision processes, strengthen science collaboration to improve speed and transparency, and engage our partners earlier and more strategically. I am deeply, deeply proud of this community of scientists, engineers, problem solvers, entrepreneurs, and leaders. I am so grateful to have a front row seat in what we accomplish every day, the jaw-dropping creativity and the teamwork that it takes. As we look forward to more discoveries in the coming year, including doing some truly mind-bending science on Artemis II, I ask each of you to join me in remaining excited and focused on reaching for the stars, as only NASA can. Thank you very much.
And once again, we're going to break for 10 minutes, so we will see you back in here then.
This is a very serious endeavor. This is absolutely a test flight.
That'll be the first time we'll have 4 crew members seeing the far side of the moon together.
We're at the point now where we are ready to go fly.
If you want to go fast, go alone. If you want to go far, go together.
We've been training together for over 2.5 years now, and with that comes a closeness.
I'm driven by the spirit of exploration. There's just something about pushing the limits that really captures my passion.
This is the stuff we dreamed of when we were kids, and now it's becoming reality.
Artemis II is more than a mission to the moon and back. It is the next step on the journey that gets humanity to Mars.
comes to Mars, everyone thought we were crazy. But sometimes, that's what it takes. We're making science fiction reality, writing the next chapters in the story of Mars exploration. But it doesn't happen overnight. Getting there is never easy.
The first powered flight by an aircraft on another planet.
It takes courage, creativity, resilience. It takes a legacy of daring, mighty things, of failing.
Come on, hear me out.
And picking ourselves back up. We've been here before. Decades of success. Building the future isn't for everyone. But for us, it's written in our DNA. We are the architects of the impossible. And on Mars, we've only just begun.
Please welcome to the stage Space Reactors Office Program Executive Steve Sinecor.
All right, good afternoon, everyone. So I want to start by acknowledging the incredible graphics team who put that inspiring video together. So if we could give them a round of applause, please do. And I want to personally thank them for giving me the challenge of presenting a static 45-minute PowerPoint presentation immediately after that. So we'll see if I have what it takes to keep the excitement going. You did, good dad joke. So I'm Steve Sinecor. I'm the program exec for the Space Reactors Office, and I'm responsible for delivering Space Reactor 1 Freedom, the vehicle you saw, the first nuclear-propelled spacecraft in human history to leave Earth orbit on an interplanetary mission. As Administrator Isaacman announced, the nation is getting underway in space on nuclear power, and we will start by flying a nuclear electric propulsion demo to Mars in December 2028 that will deliver an extraordinary science payload in Skyfall. This effort will catalyze a sustained cadence of space nuclear missions that will power the future of American space exploration. And today, I'll walk you through why we use space nuclear power, how we do it, and who will make it. Next slide, please. Oh, we're already there. Let's start with the basics. Nuclear power in space does not just enhance deep space exploration, it enables it. Through increased energy density, nuclear power will keep lunar bases operating through the 14-day, 354-hour night. It will power the missions on the surface of Mars, where without it, the alternative is football fields of solar panels that will be ineffective during dust storms. And nuclear power provides the continuous, reliable, and plentiful energy that will enable surface manufacturing and the ability to make propellant on Mars that brings crews home. Future sustained robotic or human presence missions will require the energy density that nuclear power provides. Nuclear power also unlocks deep space. Past Jupiter, the sun is just another star. Solar cell efficiency drops to 4% at Jupiter. requiring extremely large solar panels, and it's effectively zero beyond that. And for deep space missions, chemical propulsion cannot escape its own mass fraction. These are not engineering problems, they are physics constraints, and nuclear power is the answer. Additionally, nuclear-powered electric propulsion spacecraft will move cargo in space like railroads move freight on Earth, with incredibly high efficiency compared to chemical propulsion. And nuclear also brings more innovation to the game, allowing for higher power, more thrust, and eventually exotic propulsion concepts that will open up the art of the possible for future exploration missions. So, why don't we already have it? So here's the record. The United States has launched one flight reactor, SNAP-10A, in 1965, over 60 years ago. Since then, more than a dozen flight programs have been attempted and over $20 billion spent to date. But the lack of an operational space nuclear reactor is not a technology problem, it's an execution problem. There are 4 failure modes that persist through all of these attempts. First, there was no sustained mission pull. Past programs were solutions to problems that were in search of a customer. And without a deadline, urgency waned and they were unable to endure. Second, there was a scope overreach. Past programs were flagship missions, initiated before the basics were proven. The poster child was JIMO Prometheus, which was canceled at $400 million with nothing built. Third, there was a timeline mismatch, where development timelines outlasted political cycles, and visible technology progress lacked, causing programs to perpetually be vulnerable to changes in priority. And fourth, these programs had fragmented leadership. To execute, there were 5 agencies involved, with no single owner, with budget and authority from spacecraft design through flight. SR-1 Freedom is designed to break every one of these patterns. Next chart, please. SR-1 Freedom provides a one-for-one response to each of these failure modes. It has a mission pull, with being Mars-bound under nuclear electric propulsion, delivering inspirational science. And this will be the first mission in a sustained cadence, not a one-off. The scope is right-sized, with an approximately 20 kilowatt, not megawatt class nuclear reactor. And SR-1 Freedom primarily has that one new system, the reactor, on a spacecraft bus that already exists. The timeline will match the need with the next Mars launch window in December 2028. Orbital mechanics does not negotiate, and the scope must bend around this deadline. And finally, with regard to fragmented leadership, NASA will be the prime integrator and work closely with our enabling partner in the Department of Energy and any other entities to ensure all are working towards the same mission timeline. Ultimately, one manager and one office owns the schedule from design through flight. Overall, a fission-powered spacecraft carrying science to Mars is not just a tech demo. It is the first freight run on the transcontinental railroad of the solar system. It proves the U.S. can build, launch, and operate a nuclear propulsion system. SR-1 Freedom will close a 60-year gap in American space fission flight heritage. And along with our Department of Energy and industry partners, it establishes the regulatory precedent, the nuclear qualified workforce, and the flight-proven hardware that every future space nuclear mission will inherit. It is the foundation for everything that follows. So let's dive a little deeper into the mission specifics. There are 5 principal objectives that are deliberately minimal to ground the execution. 1, demonstrate nuclear electric propulsion. 2, launch in the next Mars transfer window, December 2028. 3, leverage existing hardware for cost and schedule efficiency. 4, perform Mars-relevant science and transmit incredible footage back to Earth. And 5, maximize extensibility to future higher power and longer duration missions. We are not trying to do everything. We are trying to do the hard thing, which is operate a coupled nuclear reactor, power conversion, and electric propulsion thruster system beyond Earth orbit for the first time ever. With regard to the mission timeline, we will launch into a trajectory with sufficient orbital energy to escape Earth orbit, putting SR-1 Freedom on a path to Mars. Within hours after launch, the solar arrays deploy and the systems are verified. Within 48 hours after launch, the fission reactor starts, and SR-1 Freedom electric thrusters are powered by the nuclear reactor. And after approximately 1 year, we reach Mars. Science is conducted, imagery is transmitted, and Skyfall is released. 3 of the 5 core requirements are met within the first 48 hours of launch. We will enable science at the frontier and inspire the next generation of explorers through delivery of Skyfall to Mars, which is an exciting new mission that builds on the success of the Ingenuity Mars helicopter. Targeting a future human landing site, Skyfall will deploy a team of 3 helicopters to do landing site scouting and characterization of subsurface water ice. Next chart, please. After separating from SR-1 Freedom, the entry capsule enters the Martian atmosphere at hypersonic speeds, greater than Mach 5, slowing to approximately Mach 2. Next, a supersonic parachute deploys to slow the capsule further. And finally, the heat shield separates and the helicopters are released in a first-ever mid-air deployment. The Skyfall helicopters will carry cameras and ground-penetrating radar to scout a future landing site to understand the slopes and hazards for human-scale landers. They will also map and characterize the subsurface water ice to find out where the water ice deposits are, along with the size, depth, and other important characteristics. In addition to this incredible mission, we're going to explore other opportunities, such as student-led science payloads, to further engage the next generation directly. So let's explore the vehicle a little bit more. Starting at the business end of the spacecraft, the reactor, on that far side of the screen, it will be approximately 20 kilowatts electric, fueled with HALO UO2 fuel, transfer its heat through heat pipes, and have a boron carbide radiation shield. Moving towards the electric thrusters on this side, the advanced closed-Brayton cycle power conversion system will convert that reactor heat into electricity. Moving further along the boom, which is required for separating the reactor from the spacecraft bus electronics, the large structure you see is the heat rejection system, which are high-performance, lightweight composite titanium and titanium radiators. And for the backbone of it all, NASA will repurpose the power and propulsion element to provide the spacecraft bus, the brains of the vehicle. Of note, it will provide high-rate direct-to-Earth communications so we can get that data and imagery back home, and up to 48 kilowatts of advanced electric propulsion. These are the thrusters that nuclear power is driving. So what do we mean when we say SR-1 Freedom is the foundation for everything that follows? It is a pathfinder, not the blueprint. In 2028, SR-1 Freedom provides an opportunity to fly and learn. We will gain real operational experience on a space nuclear reactor, power conversion, and advanced electric propulsion thrusters. We will establish flight heritage and set regulatory and launch precedent, and we will activate an industrial base to provide components and subject matter experts, ultimately enabling quicker follow-on missions. In 2030, we will plan for Lunar Reactor 1, and the trade space reopens. It will be informed by SR-1 data and leverages SR-1 technology, but adapted for the lunar environment. This is a new industry opportunity. We will seek input from potential providers as early as June 2026. LR1 will inherit SR1 ground and flight data on the reactor and power conversion performance, regulatory and launch approval precedent, integration knowledge and lessons learned, activated industrial base and workforce, and testing, integration, and launch infrastructure. What design space reopens for LR1 will be the reactor size and power conversion, surface thermal rejection architecture, landing loads, dust tolerance, surface ops, balance of plant optimization, and industry competition for build and delivery. And with fast follower missions, the door opens wider. We will put RFIs and RFPs on the street for providers to compete on design and cost studies and hardware development. This is the pathway from government-led demonstration to commercially built systems. And then in the 2030s, we will scale up and move into production. We are talking hundreds of kilowatts to megawatt class reactors for all nuclear applications. Higher power missions to the moon, human missions to Mars, with commercial participation and repeatable production. Overall, industry, in partnership with NASA and the Department of Energy, will power the build of SR-1 Freedom. Industry builds the major reactor and spacecraft subsystems, shielding, heat transfer, power conversion, heat rejection, and instrumentation and controls. NASA provides the spacecraft bus with the electric propulsion thrusters, power management and distribution, spacecraft structure, mission integration and operations, system integration and test, and launch. The Department of Energy provides the reactor design and integration, nuclear fuel, and launch safety analysis. And as the pictures show, a lot of hardware exists or is in development across every major subsystem, making this achievable. But make no mistake, this is not a government research and development project. This is an American industrial campaign that provides the parts and expertise needed to implement SR-1 Freedom and build the foundation for the future. Now let's talk a little bit about notional timeline. The SR-1 Freedom schedule needs to be aggressive, with significant activities occurring at NASA, the Department of Energy, and in industry. Starting now, 5 parallel work streams kick off: hardware and software development, ground test and mission operations planning and preparations, launch site preparations, regulatory and environmental coordination, and payload development. Significant design is complete and hardware development started in June of 2026. Major subsystems are ready for assembly, integration, and test by January 2028. And in October of 2028, SR-1 Freedom arrives at the launch site. And just a couple months later, we will launch and head to Mars. We will require the best of what this country has to offer, and we will need support from across the United States to achieve our objective. Space Reactor 1 Freedom will unleash American ingenuity to get America underway in space on nuclear power, enable extraordinary science on Mars with the delivery of Skyfall, and set a precedent for all future space nuclear endeavors. SR-1 Freedom will put the United States of America in the driver's seat of this enabling technology. Thank you.
Please welcome to the podium Administrator Jared Isaacman.
Okay. It's quite a day, huh? So I have a few slides to take us through at the end, and then we'll wrap things up. And shortly thereafter, we will have we will host a press conference, because I imagine there's a lot of questions that people may have. So we can talk about all these really transformational endeavors today. The real exciting stuff: returning to the moon, building a moon base, lots of great science. Multiple commercial space stations someday, building a nuclear-powered mission. There's a lot of little things that have to happen to make it even remotely possible. I mean, not to mention the whole workforce. We've got a few thousand ideas, I would say, if we can go to the next slide, that have come in from that workforce we're going to talk to you a little bit about. And that's why I began kind of my journey in this role, visiting every one of the centers and undertaking this grand information gathering campaign. What's working right here at NASA? Because we want to do a whole lot more of it. And what's slowing us down? What are some of the obstacles and challenges that are impeding progress, so I can help you clear it? And I'm going to share with you right now a little bit of some of those updates along the way. So first and foremost, restoring some of NASA's core competencies. What I found, and this probably surprises some folks, about 75% of the NASA workforce made up of contractors, and some that's not when we say we buy something from a Boeing or a Lockheed and counting their workforce. That is our workforce. About 75% is contractors, and some are in areas that make tons of sense. Cybersecurity. I don't think NASA was created as an agency to be the best at cybersecurity or IT systems. That is a great area that we should be relying on a strong contract workforce. There's other areas like turning our launch pad after every launch, where you might say, is this one of the reasons why we're not able to launch at the cadence that we once did during the Apollo era? We should probably restore some of those competencies in-house. Mission control, I'd say, would be another good example of it. So in terms of our workforce, one exercise that we have underway is converting a lot of contractors back into civil service. Then I would say also there's an opportunity to grow and mature some of the young talent that comes into NASA. Now, very fortunate for us, NASA's got a pretty recognizable logo all around the world. There's a lot of kids that want to grow up someday and join and contribute to the great endeavor that we are undertaking at NASA. Hopefully a whole lot more when they start seeing us go around the moon and return to it in the near future. But how do you grow and experience some of that talent, especially when we're not the only game in town? There's a lot of expertise in industry, and this is where we've partnered with OPM to create NASA Force, which is a component of their tech force. This gives an opportunity for industry to contribute some of their experienced talent, come into NASA as a term-based appointment, help elevate our younger talent that's coming in from our internship programs that have maybe experienced NASA through some of our grant programs and want to come here and bring some of that expertise that we're going to need, serve your country, and go back to industry, and vice versa. The same applies and allows some of our younger talent to go into industry for term rotations and bring some of their experiences back to NASA. So this is underway right now. As I often remind our team, we will be measuring success in this in the thousands, not in the hundreds, and achieved in, again, months, not years. And along the way, it actually frees up quite a bit in terms of resources for additional science and discovery. Next slide. President Trump's one big beautiful bill afforded us a $1 billion investment to modernize our infrastructure. This has been a problem at NASA if you've been following along for quite some time. I had an opportunity to go around and tour some of our facilities. I stopped at one center and there was a sign on the door that said, "Do not enter asbestos." And then I went to another center and there was a sign that said, "Do not enter asbestos and snakes." So I'm incredibly grateful for President Trump and our representatives in Congress who have given us the resources to start making some very targeted investments, and we're already deploying those resources now. One I wanted to highlight specifically is a modernization initiative at Ames for our ArcJet facility, which provides absolutely essential capabilities. One, helping us understand some of what we observed during the Artemis I heat shield, so that we can incorporate improvements going forward, not to mention contributions across industry when we're talking about things that we can maybe bring back from Mars someday and what that re-entry environment might be like, not to mention if we're going to and from the moon with great frequency in those high velocity re-entries, as well as supporting some of our other partners. So this investment in infrastructure is underway right now. I think we'll have a lot more to talk about. If you go to the next slide, you'll get a little bit of a sense of where we're starting to allocate these resources across our various centers and help rebuild some great infrastructure, but unfortunately a lot of it was built at a time when, again, NASA was the only game in town in the 1960s, and it's time to ensure its ability to support the missions of today as well as those in the future. Next slide. Brief update, for those not aware, NASA on average every year allocates about $1 billion in grants. This is a great opportunity for, again, kind of college students, those in university, to potentially get hands-on with hardware, ideally a whole bunch of instruments that we're going to require, not to mention tech demonstrations for construction of our moon base, ideally get inspired, drawn further into what we do here at NASA, and come maybe join the workforce or industry in the not too distant future. Next slide. So this is what I was referring to early on. You know, you go and you visit every one of the centers, host a lot of town halls, you can hear directly from the workforce. Again, a lot of things that are working really well. We've tried to incorporate that as we evolve our strategy. Things that are not working well, that you want to learn from, fix, better to, so you can better enable our very talented workforce. But in addition to that, we've set up a number of opportunities to submit information back to NASA, one of which is just a simple suggestion box. Put it in my end-of-year note from the end of last year. There's over 5,300, I believe, submissions that have gone into it, not to mention hundreds of submissions for policy and regulation that slows us down. Again, might have been extremely relevant from decades past, no longer relevant today. And we are implementing these across a number of workforce directives. We've already put several out. And I would say also that we've drawn input from industry as well. We've gotten, I think, somewhere close to perhaps 50 or so submissions from commercial partners as well on how we could reform some of our acquisition procurement process, insight versus oversight, and working with industry to help shape some of the requirements as opposed to being overly prescriptive. So bottom line is we're listening to our workforce, we're listening to industry, and we're trying to take this feedback because we recognize without it, we're not going to be able to do any of the exciting things that we spent the first half of the day talking about. So as I mentioned before, NASA is no longer the only game in town, and we don't have exclusivity on all the good ideas. So we welcome industry's input. We've made reference to it several times today, in fact, from science and technology instruments. I mean, we are going to have so much payload volume opportunity across all the various landers and rovers going to the moon. Give us some of your good ideas. We asked about feedback across the CLD program. We asked about public-private partnerships for new great missions of science and discovery, whether it's planetary science, science as a service. Some of these have RFIs, a lot of them don't. And this is your opportunity to be able to come in and give us feedback, submit unsolicited proposals on our front door, and I can assure you we will evaluate them and give you feedback and ideally implement many of them. Inspiring the workforce, one of my first things I put out was the ability to recognize, reward, and inspire directive to the workforce. We have a small Air Force at NASA, their aeronautics portfolio. It's something we're hoping to talk to you about a little bit later this year. It wasn't specifically one of the highlights today, but we certainly have not forgot about the first big A in NASA. And we can make great use of these aircraft to reward our workforce for contributing to extraordinary outcomes, not to mention inspire the next generation in between our various rocket launches. Fully expect to see our aircraft at various air shows, which goes to the next slide, rocket launches, public events as we celebrate America's 250th birthday. You see some pretty interesting ones. I expect our Super Guppy to have an appearance at Sun and Fun and ideally Oshkosh later, and perhaps maybe an event at Kennedy Space Center later this year. Next slide. And then it's absolutely foundational to everything we do at NASA to inspire the next generation to want to grow up and contribute to this great endeavor. And we have a number of very exciting programs that are underway right now. You can learn more about them on our website, including if you want to potentially come someday and contribute as an intern to NASA. So our next slide, as I mentioned earlier, we get some 270,000 applications. Pretty exciting. A lot of kids want to come and work at NASA. We select about 2,000 annually, and it's considered one of the most prestigious internships 5 years in a row from Vault.com. And then next slide, understanding how we communicate today. I mean, I mention this all the time when people say, does everybody understand that we're about to return to the moon like they did in the 1960s? I'm like, well, there were 3 TV channels back in the 1960s, so it's pretty easy to captivate everyone's attention. It's a little bit of a different world today. I have no doubt as Artemis II leaves the Earth and makes its grand journey to the lunar environment, it will have everyone's attention, but it'll also have their attention on Netflix and every other good streaming application that we can partner with to make sure that we are communicating our message far and wide. Next slide. Okay, so a bit of a recap for what we covered today. We started with returning to the moon. A lot of this was previously covered in late February when we had to bring Artemis II back to the vehicle assembly building. We decided to pull forward. We felt we owed it to the public at that point in time to say not only are we going to tell you our path to getting Artemis II back to the pad, but what is the more achievable approach to returning to the moon. We talked about standardizing the vehicle with respect to the upper stage, rebuilding core competencies so we could turn around at the pad faster, adding another mission in 2027 to buy down some risk, which is Artemis III. And then today we talked about how we were, well, one, we should have sent you a message too about our ability to actually pull in some of the schedule with hardware updates across all of the Artemis programs, but also to give a demand signal after Artemis 5. We are going back to the moon. We are going back to stay. That is going to require frequent and affordable missions to the lunar environment, 2 different pathways, eventually targeting crewed landings every 6 months, so we never give up the moon again. And when we get there, we're going to build a moon base. I think this is very exciting to talk about, to do it in a very logical way, a whole phase of experimentation. We never tried to build an extended presence outside of Earth before. This makes sense that we might want to do a lot of testing and experimentation and make sure we figure it out before we start building the grand infrastructure. What better way to do it? Work with our commercial partners that have already been experimenting under the CLIPS program, LTV program, get lots of landers, lots of rovers. Let's start experimenting power, communications, mobility, surface improvement, and let's pack it with as much science as the payload can possibly afford. Really evolve from, again, bespoke, infrequent missions to a templated approach with great frequency. You're going to see some of this activity in late 2026, but to really get into a rhythm starting 2027, and let's get those comm relay and observation satellites up there and bring the whole world along for the ride on the Moonbase website. We talked about staying in LEO. A very real reality. The International Space Station is an extraordinary achievement, 25 years plus of keeping human beings alive in the incredibly harsh environment of space. It cannot live on forever. We know there is an end date. That is something we are going to work with our partners on that contribute to the International Space Station. We gotta work with industry. We're very open to the original pathway. Tell us how to make it work. We're there. We shared with you our concerns. Tell us how you're going to make that work. Alternatively, here's another approach that maybe takes it in a more phased approach. Leverage the International Space Station while we have it. It's a great pathway for additional crewed missions, cargo. We have the kind of the operational and technical maturity already to help industry evolve until such time as the market that we all know is inevitable will be realized, detach away, and hopefully we're all living in a world with multiple space stations. We have to do something to help in that regard. We're not going to sit on our hands, hope the orbital economy materializes. Where we said we're going to go to 2 PAM missions a year, where you can sell the commander seat. Heck, maybe NASA buys the commander seat. I mean, that is kind of the right way to help ignite an orbital economy and not force it in place. Any of the research that has the high commercial potential, if we don't already have it in our pipeline, people were discouraged of giving the good ideas, the pharmaceutical capabilities that are gonna cure cancer or change the world, 3D printing organs. I don't know what it is. We got a front door website that was just a couple slides earlier. Submit the good idea. We want to hear it. We want to do everything within our power to ignite that orbital economy. Nikki gave an unbelievable update on science. She certainly has the best content to work with, there's no doubt. Her imagery was incredibly inspiring. So we gave you updates on some of our flagship missions. You've got Roman launching before the end of the year. How exciting, 100 times the field of view of Hubble, potentially upwards of 1,000 times the scan rate, going out and looking for the secrets of the universe. If you haven't seen it already, we actually have a mock-up of Dragonfly out in the lobby. So again, the nuclear-powered octocopter to search for life on Titan. That's a pretty exciting mission. Rosalind Franklin's coming up. We're actually going to have, think about it, have 3 nuclear-powered payloads that are going to launch in 2020, or payloads or spacecraft that are going to launch in 2028. Rosalind Franklin, Dragonfly, and SR-1 Freedom. Pretty exciting to think about all in a short period of time. We acknowledge there's got to be ways we can do science more efficiently. Time to science absolutely matters. The cost associated with it. We have a very good budget here. There's a lot of unfunded scientific missions that Nikki talked to you about that we'd love to undertake. We either will find the efficiencies internally to figure out how to pursue them, or we welcome public-private partnerships. We talked about Eric Schmidt and his foundation, the $1 billion he's contributing into planetary science. Others have reached out as well. Two other organizations reached out and said, how do we partner with NASA maybe to pursue some of these unfunded science missions? We'd absolutely love it. Surely there has to be ways, whether it's when you already have constellations of satellites being produced through factories now for various Earth observation capabilities, is our RFI going to yield any updates in terms of new scientific instruments that can be incorporated to potentially close out the gaps with some of the more expensive or bespoke satellites that we've historically purchased to get after that data, again, whether it's Earth observation, space weather, and free up additional resources to pursue some of the missions like Dragonfly that if we don't pursue, maybe no one else will. And then getting underway under nuclear power. In in space. So I find this very exciting because I think this fits squarely into what NASA is meant to do. The near impossible, again, what no one else should be able to close a business case on. That's where NASA should put our efforts. Now, for sure, industry is doing an absolutely fantastic job. Launch, observation, communication, chemical propulsion. This is what we want industry to be doing. Competitive dynamics, improving the quality of the capability and bringing costs down. That's what we want. We should then shift our attention to what no one else is capable of doing. I think the rationale there that is we want to inevitably explore farther out into the solar system where solar loses its effectiveness. This is where you want nuclear power. If you're trying to build a base on the moon, you're going to probably want nuclear power there to manage operations and keep our rovers moving in the shaded area. Certainly, if you're going to send astronauts to Mars someday, you'd really like to make sure they come back and tell us about it. Having a nuclear reactor on the surface to help with in situ resource manufacturing that we ideally already proved out on the lunar surface is going to be pretty paramount. I also call attention to that when every one of these slides is meant to convey something like really exciting, transformative, but inherent with every one of them is also a challenge, a problem, things we got wrong, real dollars that were lost, years lost. So when a lot of people ask us, how are you going to be able to do all this within the resource you have available? And I continue to tell them, NASA does not necessarily have a top line problem. We get a lot of resources. We may not always allocate them that efficiently. Steve talked about SR1. One of the first slides says we've spent $20 billion on dozens of failed nuclear power and propulsion initiatives. It's $20 billion that could have gone to other great science and discovery. Last year we spent $250 million keeping a canceled science program canceled. There's examples across every one of our mission directorates where we probably could have repurposed our resources a little bit better in the direction of science and discovery. We're challenging ourselves to do that across the board. And I have no doubt when we do find these things, we're going to be able to take on even more exciting challenges ahead. Now, back to SR1. We are making use of a lot of hardware that we already have while working alongside industry. I think this is extremely important. You don't want to pursue the 100% solution out of the gate, or you may very well wind up with another canceled program that maybe ran out of money. Nautilus was originally built to be a diesel boat. I think Hyman Rickover referred to it as the 70% solution. Well, it was the 70% solution that gave birth to the nuclear navy. And I think we're on a similar path right now. And along the way of just proving out those important capabilities in the first 48 hours after the mission launches, we are going to get to Mars and drop off a pretty inspiring scientific payload, send back also a lot of other imagery and data along the way, including some student-led science. The last thing I'll say, I don't expect any of this to happen on its own. The whole point of today was not to come and give you a bunch of great PowerPoint and then just sit and wait for it all to come to fruition. This is about action right now. It's why we're dropping RFIs. We want to hear back from people. Not weeks from now, we want to get moving. This is why we're having breakout sessions tomorrow. We're going to be available to have these conversations. Why we repeatedly refer to embedding our workforce, our subject matter experts, with every one of our vendors that needs it, every one of the subcontractors, again, every component on the critical path in an active role to help. And we know we are part of the problem in a lot of these cases. Like, we've got a lot of dated policy, things that maybe, again, made sense long ago, not always today. So let them take an active role and say, this is the right approach. Industry is telling us the way to achieve our objective. Let's let them do this. Or, hey, the supply chain's broken here. We got to build this valve. I don't know what to tell you, but we're not getting back to the moon if we don't do it. Great. That's why we're going to embed our workforce to do it, to drive outcomes. So, lot to cover right now. I'm sure there are a lot of questions. I appreciate everybody sitting through all of our presentations today, hearing from us. We can't do this without you, from the workforce to our partners in industry, and especially our international partners. We don't ever do this alone. We do it together. We're going to change the world together. So thank you.